Hi, this is Josh from Apt. We're hanging out here with JJ at Asus, and we've got new networking products. Now, something very special about this new router coming out, and you're doing some pretty wicked integration. Tell us a little bit more, JJ.
Yeah, so definitely from an integration standpoint, this is where things get really excited. Traditionally, we've only offered integration for DSL-based services. So we've had DSL modems, we've had routers that have DSL modems, but we haven't yet offered cable-based modem support. So if you were using Xfinity, if you're using Cox, Time Warner, Google Fiber type class internet service providers, you didn't have an option.
Right.
You essentially had to go with an outboard modem and then get our router. But we're really excited to now be able to offer not only outboard modem solutions, but also fully equipped high performance next generation routers, also inclusive with DOCSIS capable 3.0 modems as well.
That is awesome, because a lot of us have the modem we're renting for like $10 a month.
Yep.
And then ideally, that's our plan, is to get that dedicated router so we have the best signal.
Yep.
And the all-in-one devices provided, by the provider that I'm renting have never given us that full strength. With a router of this caliber, how is it really going to manage and handle these households nowadays that have, 3 iPhones, 2 Samsung tablets, and that whole giant gamut of streaming content and all this stuff? Let's get a little technical. What is this guy going to do for me to manage that?
So I think that's a perfect example in terms of a real world case scenario. So what we want to be able to do here is essentially enable huge pipeline support, so be able to maximize the internet speed that's being provided to the home. But then what we're going to be doing in terms of the hardware-based design, so with a unit like this, you've got advanced multi-core SoC. So essentially we've got system on a chip. It's got a high amount of memory. You're talking about high frequency in terms of the processing capability. On average, you're talking about 1.2, 1.4 gigahertz processing cores. And the great thing about this is this means this can simultaneously handle everything from being able to do packet prioritization. So if you want to be able to do multiple HD streams, 4K streams, low latency gaming, you want to be able to do voice over IP, all at the same time, the router can essentially manage all this in real time without actually impacting the performance of not only Wi-Fi, but even, let's say, USB-based connectivity or hardline-based connectivity, which is what the expectation is in a modern household, is that when a router is being used, it's not just one connection, right?
Right.
You're simultaneously maybe streaming something from the USB-attached drive. You've got 4 systems that might be hardline, and then you've got systems on both 2.4 and 5 gigahertz.
Right.
And what a lot of users don't realize is that when the processing power is a lot lower, and let's say an older generation of modems, that all hits overhead and brings down the Wi-Fi performance. So even though the theoretical number here is really, really high, we've also got the high-end hardware to be able to ensure that the performance is sustained.
Awesome. And when it's really working hard, and with all this processing power inside this box, does a router like this start to heat up, and are there like fans involved, or is it going to be pretty much just running quiet?
That's actually a really, really good question. So for the newest generation units, most of them actually have been enlarged by about 15 to 20%, so they have more actually surface area. We've done active venting on the underneath the unit. We actually have full heat sinks. So there's actually metal plates,
cool,
like what you're going to see here on some of these cards, that help to dissipate the heat. We don't want to introduce fans because fans, of course, over time potentially have the possibility of failing.
Sure.
So we want to be able to displace the heat effectively, efficiently, and also have it be very quiet, because you might have this maybe in an office environment. You might be working late at night. You don't want to hear anything.
If it's going to get noisy.
Yeah, you don't want to hear anything humming or buzzing or anything along those lines. But definitely, we also go through a very, very lengthy qualification process in terms of thermal regulation to make sure that these units operate efficiently and effectively, even in very hot ambient environments.
Awesome. And lastly, my other question is, with newer technology routers, is there a good, strong beamforming element here for some of the clients that are out in the house? If I'm in my living room with my smartphone and I'm streaming something to my my TV, is it just an omnidirectional traditional signal, or does Asus have technology that's different?
We actually have both. So with the latest generation 811 AC spec, beamforming is now inherently baked in. In previous generations, beamforming can be something that was variable, and it was dependent on the vendor's hardware, firmware, and then it also was conditional based on the client device you had, whether it was like a smartphone, tablet, TV, or whatever it might be. For this generation, we actually support 2 types of beamforming technology in our routers. One's called implicit, and the other one's called explicit. So whether the device inherently has beamforming baked into it or doesn't, we can essentially help to manage and detect the device, optimize its positioning, and maximize how we're working with it to give you the overall best range and the best experience.
Okay, so it doesn't matter if I have an AC device or an N device.
Correct.
It's actually affecting both.
Correct. With N-based devices, you're generally not going to be doing what's called explicit because it wasn't inherently baked in.
Right.
But with newer generation, like TVs that are being sold right now, a lot of those come with at least basic beamforming. Of course, the latest generation phones, tablets that are coming to market all have AC.
Right.
Notebooks, those all have beamforming baked in, and so they use explicit beamforming. So through a combination of our hardware design and our firmware, we can activate and maximize that beamforming. And then, of course, with units like this and other new routers that we have that support multi-user MIMO, that's an even newer spec which is now just starting to make its way into client-based products. That's even going to take performance and the overall way that the router works with those client devices to a whole another level in terms of performance.
Awesome. Is there a performance difference in the devices that have it baked in versus the ones that the Asus router just, realizes the client is there and just shoots it itself? Is there a difference in the quality?
For beamforming, not to a huge degree. For multi-user MIMO, though, there will be. And actually, real-world testing, we found that with units that have multi-user MIMO, whereas the units that don't have it, once you enable it, the factor of increase in performance can be in the vicinity of 2 to 4x.
Okay.
So a substantial improvement when you talk about having a router that supports that versus a router that doesn't.
Awesome. And this router's hitting the market soon?
We're targeting hopefully about a late Q1 to early Q2 timeframe. Hardware is pretty much complete, so this is how it's going to look. As always, we're really committed to making sure that the firmware experience is really stable, solid, and reliable, because that's what you want when you talk about your hardware backbone for your internet connection.
Perfect. JJ, you're awesome.
Thank you.
All right, guys, a lot more here coverage at CES 2016. Subscribe to the Apt YouTube channel to make sure you're on top of what's going down here in Las Vegas.